All right, folks, here we go with a little infection. Yeah. At the beginning of fall quarter, there are a total of 300 people in your dorm, assume. On the first day of the quarter, let's call that day 0, 2 people are infected with COVID-19. 3 days later, the total number of people infected is 5. How many people are infected in the dorms? Not dorms, in the dorm. Jeez. In the dorm after 2 weeks. Use the logistic growth model to answer this question. Okay, so first of all, let's start with that last sentence. Use the logistic growth model to answer this question. So we know that the rate of infected over time is proportional to the number of people infected times the number of people not infected. That's our logistic growth model. I'm using I instead of P here. Now, one thing I can know right away here is the carrying capacity, the max number of people in my closed environment in the dorm is 300. So let's see if we call this 1. That's our differential equation. 2. L, the carrying capacity of the dorms is 300. So that'll allow us to revise this as the rate of change of the number of people infected over time is equal to alpha times 300 minus I times I. The next bit of information that we're given is on the first day of the quarter, day 0. On day 0, 2 people are infected. So let's call that 3. The third bit of information we have here is time versus infection. And at time 0, there's 2 infected. And then it tells us 3 days later, the total number of infected is 5. So for our fourth bit of information there, our next ordered pair is 3 days later, there's 5 infected. So that's what we have to go on. So here we go. The first things first, we want to solve this differential equation. So let's separate and solve for the number of infected as a function of time. So let's see, di over 300 minus I times I is equal to alpha dt. We'll integrate both sides. This will be the integral of some kind of a over 300 minus I plus some kind of b over I di is equal to alpha t plus c2, I suppose. And then this is going to be negative a times the natural log of 300 minus I plus b times the natural log of the absolute value of I plus C1 is equal to alpha t plus C2. And because this is logistic growth, I know that A is equal to B is equal to 1 over the carrying capacity from our last video, which in this case is 1 over 300. So that'll allow me to consolidate this as negative 1 over 300 times the natural log of the absolute value of 300 minus I plus 1 over 300 times the natural log of the absolute value of I is equal to alpha t plus C3, where C3 is C2 minus C1. And then I'll multiply both sides by 300, and I'll get negative natural log of the absolute value of 300 minus I plus the natural log of the absolute value of I is equal to 300 alpha t plus C4, where C4 is 300 C3. I'll now consolidate this into a single logarithm. This is the natural log of the absolute value of I over 300 minus I is equal to 300 alpha t plus C4. I'll exponentiate both sides like a champ and clean this up as the absolute value of I over 300 minus I is equal to e to the 300 alpha t times e to the C4. And then I'll do plus or minus both sides, and I'll get I over 300 minus I is equal to plus or minus e to the C4 times e to the 300 alpha t. And I'll rewrite that one more time as I over 300 minus I is equal to C e to the 300 alpha t, where C is plus or minus e to the C4 for our consolidation. Now, if you want at this point, you can start solving for C, and you actually don't need to solve for I to answer this question. So you can. It might make things a little bit easier. Let's do that really quick. I is 300 minus I times C e to the 300 alpha t. And then we have I is equal to 300 e to the 300 alpha t minus I. I forgot my c in there. 300 c e to the 300 alpha t minus I c e 300 alpha t. Nice. We'll add this over to the other side and factor, and we'll get 1 plus c e to the 300 alpha t is equal to 300 c e to the 300 alpha t. And then we'll divide, and we get I is equal to 300 c e to the 300 alpha t over 1 plus c e to the 300 alpha t. And you can use that form if you want to. I'm going to multiply top and bottom by 1 over c, as well as e to the negative 300 alpha t, e to the negative 300 alpha t. Why am I doing that? Because it's going to clean things up real nice. This is going to be 300 divided by 1 over c e to the negative 300 alpha t plus 1. And I'm just going to, I guess I was a little premature there on what I was calling c. I guess I'll use a different letter. I'll use beta is equal to 1 over c. So this is 300 over 1 plus beta e to the negative 300 alpha t is the number of infected. There's my solution. This is my general solution. And we now need to solve for beta and alpha. So let's see here. We know that at time 0, there's 2 people infected. So 2 is equal to 300 over 1 plus beta e to the negative 300 alpha times 0, making 2 equal to 300 over 1 plus beta. So 1/2 is equal to 1 plus beta over 300. I'll multiply both sides by 300, and I'll get 150 is equal to 1 plus beta, or beta is equal to 149. So that allowed me to revise my equation. I now know that the number of infected is equal to 300 over 1 plus 149 e to the negative 300 alpha t. Now we'll use our second condition. 3 days later, there was 5 people infected. That means 5 is equal to 300 over 1 plus 149 e to the negative 300 alpha times 3. Or 5 is equal to 300 over 1 plus 149 e to the negative 900 alpha. So let's take the reciprocal of both sides. 1/5 is equal to 1 plus 149 e to the negative 900 alpha over 300. I'll multiply both sides by 300, and that'll be 60 is equal to 1 plus 149 e to the negative 900 alpha. We'll subtract 1 and divide by 149. This is 59 over 149 is equal to e to the negative 900 alpha. That means then that the natural log of 59 over 149 divided by negative 900 is what alpha is worth. Let's get out our trusty little calculator here and do some damage. Let's see, 59 divided by 149 is a small number. The natural log of that is about negative 0.926 divided by 900 negative alpha is about 0.00103 rounded to 5 decimal places. I'm going to say this again. Previously we talked about how should you round. When you're doing these logistic growth and exponential growth problems, you should probably at least go out to 5 decimal places, if not carry as much accuracy as you can. This is really 0.001029 and some change, so I'm rounding up at that position. That'll allow me to revise my equation one more time. The number of infected over time is approximately 300 divided by 1 plus 149e to the negative 300 times 0.00103 t. And so the question is, how many people are infected after 2 weeks? So I of 14, 2 weeks in, we have 300 divided by 1 plus 149 e to the negative 300 times 0.00103 times 14. So let's get out our calculator and hope for the best. Let's see, clear 0.00103 times 14 times 300 negative e times 149 plus 1 is about 2.96. So this is approximately 300 over about 2.97 if I round. Let's keep going to 5 decimal places. 2.96982. 96982. So 300 divided by 2.96982 is about 101 infected. So a third of the dorms is down, and that's only going to grow. And by the way, I just chose some random initial conditions, right? 2 people infected, and then 3 days later, 5 people infected. This number is probably wrong, but using that information, that's my projection over time, right? If we were going to make a Hollywood movie about how the COVID is spreading through your dorm, and we went to that scene where they show the map of everything turning red in your dorm, this is me doing the analysis to project how fast the infection is spreading. So see you soon, Hollywood, as I get my consultation job, right, for infection with my math degree. Anyway, that's the idea, and it's your job to go practice solving this problem start to finish with some different initial conditions and solving that differential equation. Okay.